This is podcast 2.3 for chemistry. Today we're going to talk about ions, isotopes, and how you calculate average atomic mass. So the first thing we're going to start with is an ion, and here's the definition of an ion. An ion is a charged atom or molecule. So up to this point, we've been assuming that the protons are equal to the electrons. If we think of nitrogen, if you find nitrogen on the periodic table, nitrogen has 7 protons, so we've been assuming it also has 7 electrons. That is not always the case, and when that happens, that's called an ion. So ions can have 2 different charges. They can be positive or they can be negative. And when you're talking about how atoms become ions, how do they become charged? The answer is there is a change in electrons. So it's really, really important that you understand that only the electrons change. If I have nitrogen and I want to make it an ion, I can only change the number of electrons. If you change the protons, so changing protons changes what the element is. So you are not allowed to do that. Changing protons is not allowed. We're only going to be dealing with the electrons. The next thing is there are 2 types of ions. So ions with a positive charge we call cations, and then positive or ions with a negative charge are called anions. A way that you can remember that is, I don't know if you can think, cats are good. They're positive. And then ants are bad. It's kind of silly and cheesy, but it works. So cats are good, those are cations. Ants are bad, those are anions, negative. All right, so with a cation, the deal with the cation is that your protons are greater than your electrons. You have more protons than you do electrons. What that means then is that you lost electrons because we can't change our protons, so if we have more protons, we must have lost electrons. Here's an example using sodium. This would be neutral sodium. There's 11 protons, 11 electrons. Sodium likes to lose 1 electron, so therefore it would have 11 protons still, but now it only has 10 electrons. And if you think of the charge difference there, it's a +1 because I have 1 more positive proton than I do negative electrons. We can also go with your anions. So there are more electrons than protons, so your protons are less than your electrons. And in this case, it must mean that we gained electrons. We became more negative. So here's the example using chlorine. Chlorine has 17 protons. It would have 17 electrons if it were a neutral atom. Chlorine likes to gain 1 more electron. So now all of a sudden we have 18 electrons and still only 17 protons. That difference there is a charge of -1. So you have to compare the positives to the negatives in order to figure out what the charge is. All right, you want to copy this table down because what it does is it explains how things gain or lose their electrons and what charge it will form. In your group 1A, that's the group that starts with hydrogen. Hydrogen has 1 valence electron. 2A would have 2, 3A would be 3. Valence electrons are your outermost electrons. They're the ones that do the bonding. So when we're thinking of this, say we think of sodium. Sodium would have 2 electrons in the first energy level, and it would have 8 in the next energy level, and it would have 1 out here in its outer energy level. Sodium is in column 1A, and it has 1 valence electron. They have 1 electron in their outer shell. Sodium would really like to have a full outer shell, so it can either gain 7 more electrons or it can lose this 1, leaving the full inner shell now as the outer shell. Atoms are very lazy, like most people, and they're going to take the easiest route. So it is going to be a lot easier for it to lose its 1 electron than it is to gain 7 more. So if it has 1 valence electron, it's easier to lose 1 than gain 7. Here, it's easier to lose 2 than it is to gain 6. It's easier to lose 3 than it is to gain 5. 4 is a wash. It can go either way. If you have 5, it's easier to gain 3 more to get to that full outer shell than it is to lose all 5. So they're taking whatever route is the easiest. Make sure you write this down so that you know what's going on, and we'll deal more with this later on. But you need to focus on the idea that valence electrons are your outer electrons and that each element is trying to have a full outer shell. Okay, those were ions. The next thing we're going to talk about are isotopes. Isotopes are atoms with the same number of protons but a different number of neutrons. What that means is it's the same element, it just has a different mass. We've changed the mass within the nucleus. Example, here's silver. Silver will always have 47 protons. So the atomic number on both of these will always be 47. What's changing then must be the neutrons, because in this one there is 107 and for the mass number, and in this one there's 109. So what that tells me is if I calculate the number of neutrons in each of these, 107 minus 47 is 60. Then this must be 62. So what we're doing is we're changing the mass of the element by adding or getting rid of neutrons. So ions deal with the electrons. Isotopes deal with the neutrons. Okay, next one. To represent isotopes with their chemical name, it is the chemical name dash mass number. For example, if we were doing the ones before that were this, if I wanted to write it, writing out the name, it'd be silver dash 107. This one, which had a mass number of 109, would be silver dash 109. So that's just kind of the correct way that you represent an isotope when you're writing it down. Okay, so we have examples here of potassium 39, potassium 40, and potassium 41. I know that they're isotopes because they're all potassium and they all have the same number of protons. What's different though are the neutrons. This one has 20, 21, and then 22. So how do their masses compare? Well, they differ by 1 neutron. And then we also can talk about which of these must occur the most often. Because isotopes don't occur in the same abundance, there are isotopes that are more abundant than others. And how you can figure that out is by doing a weighted average calculation, or you can look at the periodic table. So if you look at potassium on the periodic table, its average mass from the periodic table is 39.0983. What that tells me is that this must be the most common isotope of potassium because the average atomic mass is the closest to potassium 39's mass. So the closer your average mass is to one of the isotopes, that tells you what is the most common isotope for that element. Okay, ways we can calculate average atomic mass. The average atomic mass that you see on your periodic table is a weighted average, and it's just like how we figure your grade in this class. The more abundant an isotope is, the closer the average atomic mass will be to that isotope's mass, and that's what we just talked about. So if we wanted to do an example just using your class grades, how you would figure that out is if I wanted to know my class grade, in this situation, what they say is you average an 85 on exams. So I average an 85. And if I look back up here, exams are 75% of my grade. So I'm going to use the decimal version of the percentage. Use decimal version of percentage. You move 2 places to the left. All right, so I average 85 on the 75% portion of my grade. I average a 95 on labs, and that is 20% of my grade. And I also averaged 70 on my homework, which is 5% of my grade. So I've set up a little calculation here that'll let me calculate my overall class grade. So if I take all these and I plug them into the calculator, what I end up with for my class grade is an 86.25%. So overall in the class, that's what I would have. Now we can do the same exact things, but we can do it with isotopes. Here's what it looks like. Instead of your class grade, we do the average atomic mass. This is the periodic table value. Periodic table decimal number, we can calculate it. All you do is you take the percent abundance of the isotope times its mass, plus the percent abundance of the next isotope times its mass. Remembering that for the percentage, you want to use the decimal form. We have an example with this one. The first practice problem says boron has 2 naturally occurring isotopes. Boron 10 has an abundance of 19.8% and its actual mass is 10.013 AMUs. And boron 11 has an abundance of 80.2% with a mass of 11.009 AMUs. Calculate the atomic mass of boron. So atomic mass of boron has to be equal to the percentage of my first isotope, and I want to use the decimal version of both of these. So I would put 0.198 multiplied by its mass plus the next isotope's abundance times its mass. And then all I have to do is take that and put it into the calculator, and I get 10.81. And if you look at your periodic table under boron, you're going to see that that is really, really close to what is on there. So you know you did the calculations correctly, which is nice because you'll be able to check how you did based on the answers that you get. Our next question says, is helium-3 or helium-4 more abundant, and you want to justify your answer? This one we don't really have to do any math. All we're going to look at is the average atomic mass that's given on the periodic table. If I look up helium, helium has an average atomic mass of 4.002602. And I need to look, is that closer to 3 or is that closer to 4? Well, it is much, much closer to 4 than it is to 3. So that tells me that helium-4 is much more abundant than helium-3 because the average atomic mass is closer to 4 than it is to 3. Because the average atomic mass is closer to 4. And that's all you have to do for those. Okay, so make sure you understand the difference between ions and isotopes, that you can calculate what the charge would be on an ion by subtracting or adding electrons, and make sure that you're comfortable doing average atomic mass calculations for isotopes.